Greetings everyone, and welcome to our second video for section 5.4. What we're going to do in this video is do an example using the normal distribution and an online calculator. Our example is the time it takes a student to write the Stat157 final is normally distributed with a mean of 2 hours 35 minutes and a standard deviation of 10 minutes. So we do notice that the question says that it's normally distributed. Because otherwise, if you do not know that, then you're not allowed to use the normal distribution. Further, we can see that we've got the mean is 2 hours and 35 minutes and a standard deviation of 10 minutes. And so we're going to write this stuff down. So we've got that the mean is equal to mu is 2 hours 35 minutes. And we're going to want to calculate that in a single unit, and it turns out that that's 155. So 2 hours times 60 minutes per hour gives us 120 minutes, plus 35 gives us 155 minutes. Our standard deviation is sigma, and that's just 10 minutes, so we don't have to do any manipulation there. And then our x value here is equal to 3 hours, and that's 180 minutes. Now notice here that we're given x and we're asked to calculate a probability. So given the 3-hour mark, that's x, and we're asked to calculate a probability. So let's draw a little sketch just down over here. And so here's that's a little wonky, but so here's 155 minutes, and we want to know what's the probability that it would take a student longer than 180 minutes, so it's going to be a little tiny quantity here. Notice that we're given the value x and we're asked to give the probability. So if we head to our online calculator, and we're using the same one that we used in our last video, we're going to use the top option, which is we're calculating an area from a value. You just calculate p from z or x. And then notice that we've specified the parameters. We've said that the mean is 155 and the standard deviation is 10. And what we're interested in is the area above 180. So that's the area above 180 minutes. Then we just go down to the bottom. This is our answer. And you find that p is equal to 0.0062 is equal to 0.62%. And either of those our answers are totally fine. So let's take a look at part B. In a class of 180 students, how many students on average will still be writing at the 3-hour mark? So in order to do this, we're going to use the idea that the probability of still writing is equal to the number of students that are still writing divided by the total. We know that our 180, whoops, I was wanting a highlighter pen here. We know that our 180 students here is our total. We know that the probability still writing is the thing that we just calculated in part A, which is 0.062. And so if you write all that in, we get 0.0062, sorry, is equal to the number that are still writing divided by 180. And so cross-multiplying gives that the number still writing is equal to 180 times 0.062, and that's equal to 1.119 students. And clearly you can't have fractions of a student, and so we're going to round it to 1 student. Let's take a look at the last part. Part C, the fastest 15% of students will complete the exam in a certain amount of time. calculate that time. So now notice that we're given, whoops, I wanted a highlighter pen. We're given a probability, which is an area, and we're asked to find our time, which in a sense is I mean, you really want to think of it as variable t, but it's a variable x. And so again, we've got that the mean is equal to 1 hour and 55 minutes, or sorry, 155 minutes. Our standard deviation is still 10, and we want basically the probability, and we're looking for a time. The fastest 15% of students, so those students will be writing with t's that are on the times that are on the left-hand side of the graph. So essentially we're looking for this value of the variable for the area under the curve equals 0.15. So if we head on to our online calculator, you can see that once again I've chosen the second option. We're using the second option because we're taking a probability and then we're finding a value. I've input that the area that we're interested in is 0.15. Our mean is 155 minutes. Our standard deviation is 10 minutes. And then this gives us our answer. And so we find that the time is equal to 144.636. Now it's a time, and the units we've been using this problem are minutes. Now that is a ridiculous amount of precision. All of the other answers were given to basically rounded to the nearest integer. That you could also claim that the 10 minutes only has one significant digit in it. And so really it would be better if you rounded to 145 minutes, though I'm not going to fuss if you leave it with the number of sig figs that are seen in the problem, seen above. Okay, and that is our answer.